In a chemical reaction, some bonds are broken, and some bonds are formed. During the reaction, there exists an intermediate stage, where chemical bonds are partially broken and partially formed. This intermediate exists at a higher energy level than the starting reactants. It is very unstable and is referred to as the transition state. The energy required to reach this transition state is called activation energy. We can define activation energy as the minimum amount of energy required to initiate a reaction. In the case of this exothermic reaction, the reactants are at a higher energy level compared to the products. In other words, the reactants have a weaker bond and are less stable than the products. The reactants have a greater potential to react compared to products.
Formation of a typical covalent bond can be visualized as follows. If two atoms approach one another sufficiently closely for a bond to form, their outermost, most electrons are attracted towards both nuclei with comparable force. These electrons are known as the valence electrons and they are responsible for bonding. By providing energy, such as heat or light, valence electron can become excited and jump into next orbital. Therefore, the distance between nuclei and valence electron increases, resulting in a weaker bond. In this excited state, the molecule stores more internal kinetic energy, have a greater vibration, but the bond is weaker because there is a greater distance between atoms and between valence electrons and nuclei. The molecule is unstable, and less energy is required to break the bond. Therefore, the energy diagram in the exothermic reactions shows higher potential energy for reactants than for products, and less activation energy is needed to initiate the reaction. During exothermic reaction, the potential energy is transformed into kinetic energy and released into surroundings. The products store less internal kinetic energy, and form stronger and more stable bonds, hence they have a lower potential energy.
In the activity number 5, you are going to create a model of exothermic and endothermic reactions using common objects. This activity is like your biology practical where you built a model of DNA from lollies. Here is an example of such a model for an exothermic reaction. The nut and bolt represent the molecule of the reactant. It has a weak bond because the nut is only barely touching the bolt and it can move with the touch. The bond is weak, and the potential energy is high because the internal kinetic energy is high. The potential energy is transformed into kinetic energy and released as a heat during the reaction. The final product is represented by a different arrangement. The nut is upside down and screwed to the base of the nut to illustrate the strong bond. Therefore, the product has a low potential energy.